Double replacement reactions are going to take place when you have two compounds, and those compounds are going to swap partners. So what I like to do is, I'm looking at this bottom guide right here. I like to take the outside ones and I like to bond them together, and then I take the inside ones and I bond those together. So A and D are going to form a new compound, and then it's going to be CB for your second compound, because C is that cation. The cation always goes first. Remember, A always has to go first and C has to go first. So it's AD plus CB as your final products. So let's just do some examples. And when you make those new products, make sure you crisscross the charges. So for this first example, magnesium is going to bond with chlorine, and potassium is going to bond with oxygen. But we've got to crisscross those charges first. So I'm going to take magnesium, and it's in group 2, so it's got a +2 charge. And chlorine, which is in group 17, it has a -1 charge. When I crisscross those, I'm going to get MgCl2 as my first product. And then I'm going to take the other two. Remember, the cation has to go first, and that potassium is in group 1, so it has a +1 charge. And it's bonding with oxygen, which has a -2 charge. When I crisscross those charges, I'm going to get K2O. So that's my second product. And from here, you just have to balance the equation. In order to balance it, you simply add a 2 in front of that KCl. For this next example, the sodium is going to bond with the sulfur, and the calcium is going to bond with the bromine. Remember, that cation has to go first. So sodium and sulfur. So I've got Na, and that's in group 1, so it's got a +1 charge. And sulfur is in group 16, it has a -2 charge. When I crisscross those, I will get Na2S. Now I'm going to figure out my second product. I'm going to take calcium, which is in group 2, it has a +2 charge, and bromine in group 17 has a -1 charge. When I crisscross those, I'm going to get CaBr2. And from here, I would balance. In order to balance, you just add a 2 in front of that first reactant. My next example, KOH plus NaCl. Now in this example, we have a polyatomic ion, which is hydroxide right here. My potassium is going to bond with the chlorine. So those are my outsides. And then my hydroxide is going to bond with the sodium. Those are my insides. So I'm going to take potassium, which has a +1 charge, and I'm going to take my chlorine, which has a -1 charge. When I crisscross those, I get a nice KCl. Now I'm going to do my second product. Sodium goes first because it's the cation, and hydroxide is a polyatomic ion. If I look on my polyatomic ions chart, I will find that hydroxide has a -1 charge. Now that they're both ones, I can crisscross those and I get NaOH. And this equation is already balanced, so I do not have to go back and balance it. This last example has two different polyatomic ions. So NH4 is a polyatomic ion. That's our only positive polyatomic ion. That is ammonium. And sulfate right here, SO4, is a polyatomic ion that we have to be careful of. Now, ammonium has a +1 charge. Bromine has a -1 charge. Calcium has a +2 charge, and sulfur has a -2 charge. This is going to be a little different. They're not just ones. So my ammonium, with its +1 charge, is going to bond with the sulfate because those outsides are going to bond together. So that NH4 with the +1 is going to bond with this SO4 with the -2. Now that +1 is going to go all the way to the outside, and this -2 ends up on the outside of the parentheses for NH4, and it's going to look like this. NH4 with a 2 and then SO4. So I have two NH4s because each one is going to have a plus charge, and then I have one SO4 because that one has a -2 charge in order to balance out those charges. And then my last product is just calcium and bromine. So calcium has a +2, bromine has a -1. When I crisscross those, I'm going to get CaBr2. Don't forget to put that cation first. The metal always goes first.